So if we want to understand a four-dimensional or a five-dimensional triangle, let's start from the very beginning. And by the very beginning, I mean 0 dimensions. So a zero-dimensional triangle is literally just a vertex. It's really the only kind of shape there is in 0 dimensions. And so clearly, there's only one vertex and there's nothing else. So the rule for making the next higher up dimensional triangle is what you do is you add a single brand new vertex, and then you connect that new vertex to all of the existing vertices that there are with edges. And then if edges form a triangle, like 3 edges form a triangle, then you fill that in with a face, and so on and so forth. So here we have 2 vertices and 1 edge, and that literally makes a one-dimensional triangle. It really is just a line segment. So things start looking familiar and more interesting if we take that one-dimensional triangle, we add a brand new vertex, we connect that brand new vertex to the 2 existing vertices, and then we fill in that enclosed area with a new face. And so now I've got a 2-dimensional triangle, like what you think of when you think triangle. 3 vertices, 3 edges, and 1 face, right? Okay, so let's bump it up another dimension still. So here, what I've done is I've taken that 2-dimensional triangle and I'd like to pretend that it's like lying on the table. We add the brand new vertex, and then that vertex is going to connect to the 3 existing vertices using brand new lines. So there are going to be 6 edges in total. Now notice how these 3 edges together enclose a face. These 3 edges will enclose a face, and these 3 edges will enclose a face. And so there are going to be 3 brand new faces that I have to fill in. And then all 4 of those triangular faces put together will enclose some volume, and so there will be a brand new 3D piece to this tetrahedron. So as you know, 4 vertices, 6 edges in total, 4 faces, and 1 filling. One other point I want to make is it's helpful to think of this as the 3 vertices that used to be there plus 1 more, because you always add 1 for vertices. There used to be 3 edges, and now we added 3 brand new edges. There used to be 1 face, but because of what we did, we were adding 3 new faces, so we know there will be 4. Okay, so now let's try to think about what a 4D triangle is. I've drawn a tetrahedron, but I didn't color in any of the faces for clarity. But we should pretend that this is a proper tetrahedron. We're going to add a brand new vertex. Now, because I'm a 3D creature, I had to just draw this on the slides like everything else. But that vertex is supposed to be out in the 4th dimension somewhere. We have to adventure out into the new dimension to draw the dot. We follow the rule, and that dot is supposed to be connected to all of the existing vertices with brand new edges. So I decided to make one of these edges curvy just to make the picture pretty, but this vertex connects to the 4 existing vertices with 4 new edges. So that's how I have these 2 formulas. I know there's 4 plus 1 vertices in a 4D triangle, and there's going to be 6 plus 4 edges. Now, why on earth are there 6 new faces? Where are they? You know where the 4 old faces were, but see how these 3 edges form a triangle? We're going to fill that in with a new face. These 3 edges, look at that, yellow, yellow, blue, those form a triangle. That's going to turn into a new face. Use the curvy edge, this blue edge, and this curvy edge. That's going to make a new face. This little edge, this blue edge, and this curvy edge, that will make a new face. And so that's how I know that there are going to be 10 different faces to this shape. Finally, why are there 5 fillings? Well, there's the one that used to be in the old tetrahedron. And so in order to think about where the others are, you have to think, okay, where are there 4 different triangles that enclose some volume that I have to fill in with a tetrahedron? One of the easiest new tetrahedra for me to see is right here. We have this vertex in combination with these 3. So can you see how maybe you can see this blue triangle as being the base, and then these 3 gold edges will tent up towards this vertex. And so there are 4 faces there that enclose volume, and that will create a new tetrahedron. Similarly, this triangle right here has 3 yellow edges connecting up to the new vertex, and so this right here is a very floopy, floppy kind of tetrahedron, but that definitely counts. We want to count that as one of the new 3D pieces that we are filling in. One more example. Use this gold edge right here. Use that gold edge right there. And use this gold edge right here. Okay, so these 3, ignore the one in front. And that means that this blue triangle that I'm outlining right now becomes the base of the tetrahedron, and so that's an additional 3D filling. You will be able to find 4 different combinations of triangles that didn't used to be there that would fill in volume, and so that makes 4 new fillings. And of course this is a 4D triangle. There will be one brand new 4D hyperfilling. I'm making up that word, and I can't draw it, but we know that there's going to be one of them, and it's going to be there. And just to be a little more mindy-bendy, if I wanted to make a 5D triangle, what I would do is I would draw a single new vertex, and I would connect that vertex to all of the existing vertices with brand new edges, and I would try to make sense of how many edges and faces and fillings there were. It gets very complicated very quickly, but that's the procedure.